Today in section 2.5, we're going to be learning about applying the distributive property. The distributive property is a very important part of algebra. You will use it almost daily over the next several years. There are quite a few vocabulary words for this section. The first one is equivalent expressions. Equivalent expressions are two expressions that have the same value for all values of the variable. Because what we're going to be doing today is taking an expression, changing it by distributing. The numbers and things will look a little bit different, but they'll basically be two expressions that have equal values. The distributive property is one of the properties that is used to find the product of a number and a sum or difference. The terms are the parts of an expression that are added together. And we're going to be looking at examples of all of these throughout the lesson today. A coefficient is the number part of a term with a variable part. We're going to be identifying all of these in just a moment. A constant term is a term that has a number but no variable part. And like terms are terms that have the same variable parts. In our first box, we're going to be looking at the distributive property through a purely algebraic form with no numbers, just variables, and purely with numbers. So what we like to look at when we're doing the distributive property is we like to say we're going to multiply a times b and a times c. That's going to leave me with ab plus ac. Or here, the a can be on the other side, so that would be BA times CA. Those are basically the same thing, though. The same thing with subtraction. AB minus AC, or backwards, AB or BA and CA. With numbers, this is 4 times 2 plus 4 times 3. 3 times 2 plus 5 times 2. 7 times 5 minus 7 times 3. Or 9 times 6, or 6 times 9, minus 4 times 9. In example 1, we will apply the distributive property with a mixture of numbers and variables. And what we're going to do is get an equivalent equation. The note off to the left is very important because it says to be sure to distribute the factor outside of the parentheses to all of the numbers inside the parentheses. One of the most common mistakes is that students will multiply the first term but not the second one. So in A, we have 4 times A, which is 4A, plus 4 times 3 is 12. And that has been distributed. That is what our answer will look like. Or we can do A times 6, which I will write as 6A, and 5 times 6 is 30, so plus 30. In C, 3 times x is 3x, and 3 times 8, and that's a minus sign in there, is a minus 24. And for D, 4 times x is 4x. Here's something a little bit different. X times x. That's going to leave you with x squared, and we're going to have a minus sign between those. Signs are also something that can trick a lot of students into having maybe the numbers right, but not the signs correct. In example 2, we're now going to look at what happens when you distribute a negative number. So the negative numbers outside of the parentheses with the terms that are being added or subtracted. So I'm going to do negative 3 times 7 plus and negative 3 times x. But we're going to simplify this. We distributed our negative 3, and now we're going to simplify. Negative 3 times 7 is a negative 21, and negative 3 times x is a negative 3x. Instead of saying a plus a negative 3, I'm just going to say minus 3x. And that has been distributed. In B, we'll do 6 times negative 2a minus a times a negative 2a. So we distributed the negative 2a. 6 times a negative 2 is negative 12a. And what we're going to be left with on the other side is a negative 2a times negative a times a negative 2a. The negatives are going to turn into a positive, so it's going to become plus 2a squared. That's what we get when we simplify. In our checkpoint, we're going to use the distributive property to write an equivalent equation. So 5 times n is 5n, and 5 times a positive 4 is a positive 20. So 5n plus 20. And in 2, this is almost like saying you have a negative 1a, if it helps to have a number in front of it. Negative 1a times 3 is going to give you a negative 3a, and a negative 1a plus a gives you a minus a squared, because you did a times a, and that is your answer. Pay very close attention on your last page of notes, because you will have examples like this, problems like this on your homework, where you're going to have to identify the parts of an expression. Especially when we get to checkpoints 3 and 4 in a moment, watch how I'm answering them. Watch how I'm showing the work, how I'm writing it down, because that's how you're going to want to do it on your homework assignment. Let's start with example 3 though. We're going to identify the parts of an expression. We're going to find the terms, the like terms, the coefficients, and the constant terms in this expression. But before I can work through it, I need to change this to completely addition. So watch how I do this, how I break it apart. The 2x, which is positive, it's just going to stay the same. In fact, that first term will stay the same. But I'm going to change that to a plus a negative 5. What I'm trying to do by doing that is to take away the minus sign so much, but replace them with plus signs. But the minus sign cannot go away, because that negative is important. But if there's a plus, like the next part, plus 8x, the plus signs won't change anything. And then the last part would be plus a negative 3. And notice how we put the negatives in parentheses to separate the plus signs and the negative signs. Now to identify the terms. The terms are each of the separate parts. It is the 2x, it is the negative 5, it is the 8x, and it is the negative 3. They are all the things that are broken up by the plus signs. The like terms are going to be the x's. 2x and 8x are like terms because they both have an x. Negative 5 and 3 are like terms. Negative 5 and negative 3 because they're both numbers. The coefficients are numbers. No variable involved here, but they're the numbers that come in front of a variable. So the coefficients are the 2 and the 8 because the 2 comes before the x and the 8 comes before the x. And finally, your constant terms are the numbers that stand by themselves. The negative 5 and the negative 3 stand by themselves, so they are constant terms. So on checkpoint number 3, before I actually start listing out the different parts, I'm going to write out everything that I'm looking for. I'm looking for terms. I'm looking for like terms. I'm looking for coefficients. And I'm looking for constant terms. And on the questions that you'll have on your assignment where you have to list all these things out, this is what you're going to want to put. Now, before I can actually list out everything separate, I'm going to take my whole problem and I'm going to change all the minus signs into plus negatives. So the first one's going to stay the same. It's going to still be a 10 plus 3a. That doesn't change. But instead of a minus 4, we're going to put plus a negative 4 and a plus a negative 6a. Some of the terms are the 10, the 3a, the negative 4, and the negative 6a, each separate part of that. The like terms, 10 and negative 4 are like, and 3a and negative 6a are like. The coefficients are the numbers in front of the a's, so 3 and negative 6. And my constant terms are the numbers that stand by themselves, 10 and negative 4. And for number 4, we will do the same thing that we did for number 3. We're going to list out terms, like terms, coefficients, and constant terms. Okay. In this one, the 7y is positive, so we're not going to change it. But that minus 11 is going to become a plus a negative 11, plus a negative 4y, disregard that line down the page. Let's see if I can erase it. And plus a negative 1. The terms are 7y, negative 11, negative 4y, and negative 1. The like terms are 7y and negative 4y, and negative 11 and negative 1. Our coefficients are the 7 and the negative 4, and our constant terms are the negative 11 and negative 1. And that concludes section 2.5.